Okay, in this video we're going to go over the Chapter 3, which is addition and subtraction. So in 3.1 they talk about interpretations of addition and subtraction, so I've typed up some notes here, so we're just going to hit the high points of them. Okay, vocab words right here. In an addition problem, the two numbers in this situation, the A and the B, which are said to be non-negative numbers, they can be called terms, add-ins, or summons. We tend to, in the higher levels, call these terms. In terms of developing a word problem for A plus B, what if I said that we had 5 fish, and then we bought 2 more. So, and then bought 2 more. 2 more. So more is a addition word. So what would that look like? So if my A was 5, so that would be 5 plus 2, and then you would say that that would be 7. Okay, in terms of vocab for the subtraction, you can call them terms, which, as I said, is a common phrase for us to use, or you can divvy them up a little bit, and if it's a problem that's A minus B, A is going to be the minuend, and B will be the subtrahend. So, subtrahend meaning that which is going to be subtracted away from the other term. Okay, so develop a word problem for this. So you can say, on the shelf we had 12 books. So if we had 12 books on the shelf, that would be my 12, and I would write this out in the words. Then we took 3 books away, so we took it away, so that's 12 minus 3, and that's going to give me 9. Okay, the word problems are important because I tell my kids, and this is a higher level, about to go to college kids, that life is a word problem. So they tend to not like word problems, so the sooner they can get comfortable with them, the better, and critical reading skills are essential when dealing with the word problems. So let's go on to the next slide. Okay, in this topic they are saying that we can relate addition and subtraction equations. So they mean by that you can turn any addition into a subtraction and vice versa. So now we're going to create a word problem and the companion strip that goes with it. So let's say that I can say Mary had 3 dogs. Okay, so here's my 3. This is what she has. So she had 3 dogs. Then her family was given 2 more dogs. So here's her additional dogs. How many dogs do they have altogether? So your connection is going to be the 5. Alright, so that's the addition mapping. But can't you also write this and read it as a subtraction? So what if I said Mary has 5 dogs now? Okay, so she has 5 dogs now. Her family was given 2 dogs. Alright, so how many did she have originally? And that would be 3. So you can pretty much use the same companion strip, but you're going to just view it in a different way. So in this situation, we know that she had 5, so she had 5 altogether. And we know that her family had been given the 2 dogs. So then the question is, how many did she have initially? So that is your subtraction problem. Okay, when we did the addition problem, we instead said she had 3, they added 2 more, so she has 5 in total. So the more comfortable you can get with having your students go back and forth between these at a very basic level, the better it will be for them going forward in math. I've always enjoyed the change-making problems because I think that is a lost art. And if you have, like when we have kids sell things in our dining hall, they have to make change themselves. And it's always interesting to see how they start out doing that. So it's a great thing if you can have them observe people making change. It is harder and harder to do that because the cashiers nowadays just let the cash machine do the change for them. But so you may have to do this in an ad hoc manner. So I said, let's think about if we can set up this kind of problem for a shopkeeper's method of subtraction. It's one of the problems that they do in the class activity. So what if we keep it simple and we just say we're going to purchase 2 candy bars when we go to the store, and each candy bar costs $1. So the cost of our candy, so the cost of the candy is going to be $2 because I bought 2 candy bars at $1 each. I give the person a $20 bill. How do you make change from that? So the first way you can do it is you can just say, okay, I'm going to do a basic subtraction. I have 20. I take $2 away. I'm expecting $18 back. And then you have your basic strip where you have the 2 that you have spent, the 20 that you've given, and what you want back. You want the 18 back. Alright, so that's easy enough. Many, many times it is the most efficient way for the children to make change by doing the counting up method. So this, in effect, changes your problem from a subtraction problem to an addition problem. I know that I've spent $2. I'm going to get some amount back because I'm giving in 20. So that amount should, when combined with my 2, add up to 20. So what you can do is start counting with 2 and then start adding out the bills. So 2, 3, 4, 5. Maybe you'd have the 3 singles, then put another 5, that's 10, and then a $10 bill, that's 20. So for the advanced kids, you can do all kinds of stuff with this method. But the count up is the shopkeepers approach. Okay, so this is going to be 18 here. They will count out 18. They will always have the change correct if they go through that method. So going back into the textbook, the next topic is other addition and subtraction scenarios. So addition are the add to problems, while subtraction are the taking from problems. And these problems generally involve a period of time, and so they're often called change problems. Something's changing in the scenario. So then the author identifies 3 subtypes of the change problems. One is result unknown, the other is a change is unknown, and the third is the start is unknown. So we're going to practice this concept using the class activity 3B on the next page of these notes. Okay, here are the first 4 problems of the class activity 3B in the back of your textbook. So in the first problem, the subtype is the result is unknown. So this is a result unknown problem. So think of a word problem that you can have. I said, for example, if Mary had 6 pens and then she purchased 9 additional pens, how many pens does she have in all? The result is unknown. You would add those numbers and you would get 15 for your answer. Okay, the next problem is 6 plus something, and notice, or I noticed, that they're not introducing variables yet, clearly, but you can see how this will naturally go into a variable problem when the question mark becomes an X. So that's just a little aside, but so let's keep going. So 6 plus something equals 15. So the 6 that was the original thing they had has been changed by something. So what is that? We don't know. That's what we're looking for. So this is a change unknown problem. So if I said that, okay, Susie had 6 marbles, so she had 6 marbles, and then, we'll put that in a little box, then her mom went out and bought her some additional marbles, And when she counted the marbles, she had 15. So now you're looking for this value right in here. So 6 plus what gives you 15? And that something is once again 9, as it will be every single time. But this is a different format of the problem. It was the change unknown. Okay, this third problem, you have an unknown start. So it's a start unknown problem. So your first box is the unknown. So we're not certain what this is. And we find that, so let's say John had some M&Ms and he added 6 more to his package of M&Ms. When he opened the M&Ms and spilt them out, he discovered that he had 15 in all. So if he had 15 at the end, and he was given 6 additional, then he must have had 9 to begin with. So start unknown, the start was 9. Okay, this last one is a result unknown problem, but now it's a result unknown as a subtraction. Alright, so this is what the scenario is going to be. Here's our 2 terms. We know that we are beginning with 15. Okay, we're taking away 6. So the question is, how much remains? So what remains will be the 9. Okay, we have 2 more problems on the next page. Okay, here we have a change unknown problem for subtraction. So change is unknown. So initially, we had 15 in our set. We take away some number, and then we end up with 6 remaining. So the change was unknown. The change is going to be 9. So 9 got taken away from the original 15. So then the last one, the start is unknown. So we have some number here. We take away 6, and we have 9 remaining. So what was our initial amount at the start? It was 6 plus 9, which is 15. So that's a whole bunch of writing add to and take from problems. So let's move on to the next topic. Okay, this section covers put together, take apart problems that don't involve change over time. So create word problems for one of each type using strip diagrams or number bonds below. Okay, so if there's no change involved, you're going to combine a part and a part to get a whole. So what if you said that Sue had 5 shells? So she has 5 shells. Mary combines her shells with Sue, and Mary had 6 shells. How many do they have altogether? So that's going to be a put together. Part of the shells came from Sue, part came from Mary, and when you put them together, you have 11. Okay, you can also express this by having 11 here as the unknown, and then your 5 and your 6. Okay, so the total is unknown there. What if an add-in is the unknown? So in that situation, and because of the space here, we'll just use the little number bond method. So what if I said that Joe had, so Joe is going to have 12 stones. Fred gave him some. Okay, so Joe has the 12. Fred gave him some, but I'm not sure what the sum he gave was. But after the boys count the stones, they now have 17 in all. So here's your add-in that's missing. So 12 plus the 5 gives me the 17. Okay, there's one more example on my next page that has both add-ins are unknown, and in that case you could get several different solutions. So we'll do that next. Okay, so here with both add-ins unknown, why don't we develop a word problem? So what if we said Cheryl and Amy combined their scented markers, and when they combined them, they counted them, and they discovered they had 15 in all. So what possible combination could they have had to begin with? So if you pick a 10 for Cheryl, then Amy would have had a 5. But there are many ways to do this problem. The end result is still 15, but what if I reduced the 10 by 1 to a 9 and increased Amy's count by 1 to a 6? That's going to be 15 as well. What if I gave a dozen to Cheryl, so she had 12, and then I had 3 that I attribute to Amy. So they still had 15 when they counted them together, but now you have a different option of having 12 for Cheryl and 3 for Amy. And that could end up being a good discussion of different ways to combine numbers and different tricks you get in picking your numbers. So that's the end of that little topic. We're going to go on next to compare some of the problems. So I typed up a little explanation about compare problems. So compare problems are addition and subtraction problems that involve the comparison of two quantities. So there's a larger quantity, a smaller quantity, and the difference between the two quantities. So we have 3 different types of problems here. So you have difference, unknown, you have bigger unknown, and you have smaller unknown. So I'm using class activity 3C, and the first one just says, let's just do another put together take apart. So we're going to do an add-in unknown problem, and then after we figure it out, then I'm going to throw in a quick comparison. Okay, so if I say that, so Juan has 10 pens, Julio adds his pens to Juan's pens, and together, so I don't know how many Julio has, but together they now have 17 pens. Okay, so here's the together part, 17. I have an add-in that's unknown. I had a 10. Here's my unknown add-in, which I end up saying is going to be a 7. So here is Juan's contribution, and here is Julio's contribution. So in terms of comparing, which young man put more pens into the bundle? So you would say that Juan did. And then you can say which one put fewer in. And you could say Julio did. So you can turn any problem into a compare problem. And then you can even, start doing some symbols. So Jack had more, so he had more than Julio's. Read it backward. Julio had less than Juan's. Okay, so there's your put together, but then you can have it be a compare as well. Okay, the next thing says 2 versions of compare difference unknown problem. One formulated with more and one with fewer. Okay, so I'm going to say Mary has 15 pens. Sue has 10 pens. So how many more pens does Mary have? Okay, so let's think about that. If Sue has 10 plus some other number will give me the 15 that Mary has. So it looks like I want to say that Mary has 5 more than Sue. Let's go the other way. How many fewer pens does Sue have than Mary? Well, Mary has 15, so I take away some unknown number, and I end up getting 10 pens. So it looks like Sue has 5 pens less than Mary. So one was a more, and one was a less. So we're comparing the numbers. So again, Mary, her pen number is greater than Sue's, or Sue is less than Mary, and the difference in either case is 5. So let's go on to the 2 more problems that are under our compare problems. So the problem type for number 3, it says we're going to do 2 versions of compare. The bigger quantity is going to be unknown in this situation. So how about if we say Mary, we're back to Mary. Mary has 5 hats. Okay, so here's Mary. She has 5 hats. Sue has 3 more than Mary. So if she has 3 more than Mary, then to get the number of hats that Sue has, she's up here. We're going to add the 5 and the 3. So the 3 was what I was looking for. Well, the 3 is what I'm going to utilize to figure out that Sue has 8 hats. So Sue has 3 more hats than Mary, or you can say that Mary has 3 fewer hats than Sue. Okay, so again in this situation, Mary has the 5, so Mary has less than Sue, or you can say Sue has more than Mary. Okay, and the last one here, 2 versions of compare the smaller unknown problem. So if I say that, let's say Anne has 10 of those really pretty feathers. So she has 10, and Sue has 7 less. Okay, so 10 is up here with Anne's feathers. Alright, then Sue is going to have 7 less. So what must Sue have? Sue must have 3. So you can say Sue has fewer, 7 fewer, or you can say Mary has 7 more. Okay, so that's activity 3C. So let's go on to the next page. Okay, in this section, they talk about problem language and why we can't only rely on keywords alone. Okay, so I will say that this is an issue at every level of math, and that there is no substitute for really stressing critical reading skills. Okay, so I looked at a problem in class activity 3D, and they want us to identify the type and subtype of the problem and formulate an equation that fits with the language of the story, and identify the language that might cause students to solve the problem incorrectly if they rely only on keywords. Okay, so Claire had 3 bears. After she got some more bears, Claire had 12 bears. Okay, so you have to read this carefully, because here Claire is sitting with 3 bears. These are stuffed bears, by the way. Okay, so then she got some more bears. Claire had 12 bears then. So what is missing there? You should be thinking that the add-in is missing. So I don't have a value here. How many bears did Claire get? So Claire is going to get 9 additional bears, okay, because that will give me the number I need. Now, why could this possibly be a confusing problem? Well, let's see. Claire had 3 bears after she got more bears. You sometimes can just, what my kids will do, is they have 2 numbers. I think I'll add them together, and they would then think that Claire has 15 bears at the end, that it was the 12 more bears that she got here. But that is not how the problem is worded. So you may want to ask your students, what could they possibly do incorrectly here, and how can they make sure not to do this? So it's all in the setup. Once you diagram it, so you can either use, strip shapes or whatever you want to use, but if you have them go back and use the diagram to make sure what they have written in the diagram now matches the wording, that is going to solve a lot of problems, and it will get them in a habit of looking at their sketch, looking at their diagram, looking at their calculations, seeing is the answer reasonable. All those good skills will come about if you just have them reread it and look for the correct insight from the problem. Okay, the next thing we're going to do is talk about relating addition and subtraction on the number lines, where you can relate the length by putting it right on top of the number line. It's a very nice way to make sure they have a good handle on what the math is that they are indeed doing. Okay, on this page I've drawn a number line which starts at 0, which is critical, and I have my 2 boxes just like I've had in previous examples, only now they are directly above a number line. So I know that in this first box I have a length of 3. So the number I'm going to be adding is 3 plus another length of 1, so that is 4. And I can tell from the shape and the length of the number line that I indeed do have 4. Okay, what addition did I just show? I just showed 3 plus 1 equals 4. So what if I wanted to do a subtraction instead? So what you can do is you can double back on the number line. So in this situation, just to go over this again, I'm starting here, and I moved here on the number line, and then I moved 1 more jump on the number line. So the first jump was 3, 1, 2, 3, and the next jump is just 1. Okay, so I'm going to set up a subtraction, and we'll demonstrate that in just a sec. So let's start our subtraction. Let's say initially we had 4. So we have jumped from 0 to 4, and that distance is 1, 2, 3, 4. So what if, I'll change colors, what if we wanted to go back 2? So we're going to go from 4, and we're going to jump back 2 more. Whoops. So let's go to 2. So what should we do now? Well, let's indicate that we now have a box that starts at 2 and ends up going back. So our box this time, I'm going to color it in so that our remaining box is this red box. And that illustrates that we now have less than we had before. So we only have 2 left. So we started at 4. Whoops. We started at 4, and we went back 2. So I can see that my box landed right here in the red, which only gives me 2 lengths on the number line. So that would be a subtraction problem that you can illustrate this way. Okay, in 3.2 they talk about some very important concepts. Commutative and associative properties of addition and mental math, as well as single-digit facts. So all of these are critical. They're critical at various levels. So the first topic is parentheses in expressions with 3 or more terms, and the associative property. Have your kids understand what these words mean. If you have more than 2 terms, you can associate them differently with addition. Okay, associative really just means moving those parentheses. Now, they don't initially start to tell you why you'd want to move the parentheses. So we can see right here, clearly that's going to be easier to add than is 99 plus 53. So we're going to move them for a reason, but first you have to understand that we are allowed to move them. Okay, so either way, you'll get the same answer, but you might get to 152 quicker if you are associating in this regard. Okay, the commutative property of addition means that you can move the numbers. So A plus B is the same as B plus A. You can also do both the commutative and the associative property with addition at the same time. So you would do that by, say in this problem right here, if you end up saying 1 plus 99 plus 52. That would be a combination of the commutative property and the associative property. So these are just very valuable properties, and they allow for greater flexibility in calculating sums, and they also open the door to some mental math. So there was a very valuable line right here. It says how we view the equal sign in equations showing the commutative and associative properties is really important. So you want to stress that the equal sign really means is equal to, or it means is the same amount as. Don't say that it means go ahead and calculate the answer, because that's going to confuse matters when you're trying to demonstrate the associative or the commutative properties. So make sure that when you use the equal sign, that you truly mean the quantity on the left is equal to the quantity on the right. Okay, so then they talk to us about children's learning paths for single-digit facts and the commutative and associative properties of addition. So class activity 3F was kind of interesting because it really clarifies these levels. So the direct modeling is when you're going to count on. So say you would try to be adding, very simply, say 5 plus 3. So say you had your fingers. You would count your 5 fingers, 1, 2, 3, 4, 5, and then add on 6, 7, 8. Okay, that's level 1. They all usually start about there. Okay, another way they can do it is the level 2 of counting on is you count on from the very first number. So the 5 plus 3, the 5 happens to be the larger number, but even if it wasn't, you would say 5, and then you would say 6, 7, 8. Sometimes they use touch points for this as well. So some schools teach with touch points, but in any event, you're counting on. A slightly more sophisticated way to do it, let's say you had 6 plus 2, but it was presented to you as 2 plus 6 initially. So the child could, if they understand the commutative property, is they can say, oh, well, this is equivalent to this. That would let them count on from a larger number. Start with 6 and add 2. So that would be a more efficient process, and it would be recognition of the commutative property as well. So that's levels 1 and 2, and then we'll do level 3 on the next slide. Okay, when we reach level 3, they are using addition facts to find related facts. So this is considered the derived fact method. So there's a couple of different ways you can do this. One is make a 10 method, and you can use the associative and the commutative properties in doing this method. So for example, if you had 7 plus 6, you know that that equals 7 plus, well, 6 is 3 plus 3. So if you write 6, knowing the number fact that 6 equals 3 plus 3, then you open the door to be able to group to make a 10. And because you know the associative property, you can get to this level. Now you're going to associate 7 and 3. That gets you the 10, plus 3 more, you're at 13. Okay, you can depict this grouping by using boxes as well, boxes of 10. So I have 7 red dots and 6 blue dots. So if I want to group by 10, because I'm going to add all these together, my 7 are right here. I then pick up 3 more of the blue. That gives me 7 plus 3 is 10. And then it's easy enough to count 3 more. So 10 plus my 3 will get me back to 13. Okay, there are other derived methods. You can make a 10 from the larger of the numbers. Okay, you can work with doubles and add 1 or subtract 1. So if you know that, for example, if you had 4 plus 4, you would know that's 8. If you have 4 plus 5, you might still go for your doubles and say, oh, well, 4 plus 4 is 8, and 1 more, so plus 1, makes 9. Or you can go 1 down. 4 plus 3. Well, 4 plus 4 would have been 8. Go 1 down, and that makes 7. Okay, so these are more sophisticated ways that you can use your addition facts. It also makes your student very flexible in their thinking process, and that will also always help tremendously as they go forward in math. So on the next page, we're going to view subtraction problems as unknown add-in problems and work through class activity 3G. So on this page, we're just going to do the first 2 levels of subtraction problems. So the direct modeling approach is when they count out, for example, for this problem, 8 minus 3, you would count out 3 and then actually physically you would count out 8 and then physically remove 3 from that 8 to give you 5. Okay, so that's just direct modeling. Level 2, what you would do is you'd say, okay, I have 8 minus 3, but I can view that as an unknown add-in problem, which is going to switch this subtraction to an addition. Okay, this is clearly a little bit more sophisticated. So you can add on from 3. So 3, and then count up to 8, and you know that you've added 5. So those are level 1 and 2. Let's go to level 3 next. Okay, in level 3, we're getting into some sophisticated methods of doing some mental math, really. So make a tens method is one of the level 3 methodologies. And this first one is make a 10 with the unknown add-in. So that means you're going to take a subtraction problem, which is 15 minus 6, and you're going to view this as 6 plus some unknown add-in. So if you are looking and you're saying, okay, I need to get to 15, in terms of knowing some tens grouping, you can say, okay, I'm going to add 4 to that. So if I add 4, I'll get to 10. Then you add 5 more to get to 15. The 4 plus the 5 more is 9. So that's a nice way to think through the problem. Okay, another way is if you're going to say subtract from 10. If you have the same problem, 15 minus 6 equals something, the child views 15 as not just 15, but as 10 plus 5. And you're going to subtract 6 from that. So it's pretty easy to subtract the 6 from the 10, and you get 4. Add that 4 to the 5, and you're up to 9. Okay, so what's another method? Same problem, 15 minus 6. This is also a make a tens method. The child's going to break down your 6 into 5 and 1. So instead of viewing this as 15 minus 6, we're going to view it as 15 minus 5 minus 1. and you're going to subtract the 5 from the 15. That gives you 10 minus the 1 is 9. So all of these methods work. Sometimes one method is easier than the other given the numbers, but it's a very nice drill for your kids to think about these patterns and why they work and if they work. And it'll make them much more flexible in terms of their math approach. Okay, so under mental methods for multi-digit addition and subtraction, one way to do this is to make a number a round number so it's easier to work with. So look at this first method, and this gives me opportunity to talk about lining up your equal signs. Make sure that what you have on either side of the equal sign is indeed equal. So initially we had 245 plus 298. So I know that's equivalent to taking 2 away from 245 to get 243, and add that 2 to the 298 to make that 300. It makes my adding go a lot quicker. So that's one method. Okay, rounding and compensating. Very similar. Again, make sure that what you have on the left side is indeed equal to the right side and line them all up. Okay, the textbook tends to take this and say equals and then 543. I would highly recommend you not do that. Keep your equal signs equal all the way down so that you can follow the reasoning, and it's a good method for the kids as they get higher in math. Okay, so the rounding and compensating, you've got to look ahead a little bit, and you say, okay, if I'm going to make I'm just going to make the 298 300, so I can make it 300 by adding 2, but in order to keep my balance book balanced, I had to subtract the 2 away, and that will get me the answer a lot quicker as well. Okay, subtraction problems as unknown add-in problems. You can switch it around. You can say 16 plus some number equals 325, and that's always, a way to get around doing a subtraction. So one more little thing to tell you about. Be really respectful of this equal sign. It's so very important that they have a good idea of where this is placed and what it actually means. Class activity 3H. They ask you how you would do this kind of problem carefully. So what I think I would do is the following. On the other side of the equal sign, I would say 253 minus the 100. Now, I don't really have 100 to subtract. I really have only 99, so I have to add the 1 back in. And they go through a whole bunch of these problems, and they go through, child confusion as to, do I add the 1, do I subtract the 1, what do I do? So once again, keeping your equal signs all balanced is very important. So we're going to go on to the next page in just a sec. Okay, in this last section that we're going to do in this video, 3.3, they talk about the standard algorithms for adding and subtracting numbers in base 10 and why they work. So first off, what is an algorithm? An algorithm is a method or a procedure for carrying out a calculation. Okay, the addition algorithm, based on the base 10 system, is all about grouping groups of 10. So when we use the standard algorithm, we line up our numbers in columns when we add, and then we use regrouping, which is you can also call trading or carrying or whatever else they use it. They say about it now. So in terms of lining things up, you've got your 135. You put your operation someplace out here. The 82 lines up, and you start from the right, and you add your columns. And so here is your regrouping and carrying. Okay, so I get 217. If I want to do that visually by doing a math grouping, what I would do is the following. First, I would have to write 135. I represent that as a group of 100, and then I would need 3 groups of 10, so let's make straight lines 10s, and then 5, so I think I can do little dots with this. 1, 2, 3, 4, 5 little dots. Okay, so that's 135. Then let's go down to the next number. I need 82. So I need 8 groups of 10. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to need 2 little ones. So I have a 1 and another little 1. And I have no hundredths. So if I'm going to add these together, I start from my right, and I have 1, 2, 3, 4, 5, 6, 7. Not enough to make a group of 10, so I write down my 7. Then I'm going to see how many 10s I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is a new group of 10. That's going to come over and become another group of 10. So all I have left is 1 10. I now have 2 hundredths, and that matches up. Okay, you can also do this in expanded form. If you're going to write the numbers in expanded form, you're going to write, 1 times 100, and then plus 3 10s, plus 5 1s, and then plus, you have 8 times 10, plus 2 1s. So starting from the right, I have 7 1s. I have 8, 9, 10, 11 10s. Whenever I have 10, it's going to go over. So one of these will go over and leave me with only 1 10. Okay, so we'll make that a 2. I have 1 10. Now I have another 100 that I brought over in a very messy fashion. But you get the idea that there are many ways to represent this. So we're going to go next and talk about the addition algorithm for decimals. Okay, when dealing with decimals, you can do a base 10 drawing, but you're going to define your groups differently. You can write in expanded form, but you do that differently as well. You're going to bridge everything to the column type of addition. So let's do that now. And we'll stress the importance of lining things up on the decimal. Okay, now some teachers will teach if you have 3 places after the decimal, you want to have that in every number, so you can add zeros on to the end of the first number. Now you're going to start from the right again, and you're going to add 6 and 4, which gives you 10. You have to carry 1. 3 and 1 is 4. I have a 2. Bring your decimal, and then you have a 1. So that works for decimal addition every time. Okay, we'll go on to the last page, which is the subtraction algorithm, in just a sec. Okay, I've set up the subtraction algorithm. So we're going to use, we could use the column method with borrowing and regrouping, and I'll do that in a second, but I was first going to do the base 10 drawing. So right here, I have 125. So right here is 125. Okay? Beneath it, I have 62. So here's 62. And I am subtracting those 2. So when I look, I'm going to work vertically from the right. 5 minus 2 I can do, but right away I see I have 2 10s, and I'm trying to subtract away 6 10s. That's not going to work. So instead, I'm going to take my group of 100, which is right here, and I'm going to instead break these up. So I'm going to break it up into 10 ones. Alright, so that's what I have done. So now I'm going to try to do my vertical subtraction. So I put my line indicating I'm going to subtract right here. And then I say 5, here's 5, minus my 2. That gives me 3. Because I took these 2 away, that gave me 3. Now I have my 10 10s plus 2 more, and I'm subtracting away 6. So I need to take these 6 away here. So if I take these two, that's 2, 3, 4, 5, 6, I'm left with 1, 2, 3, 4, 5, 6, 6 tens, and my answer is 63. If I wrote this out in my column method, 5 minus 2 is 3. 2 minus 6 I cannot do. I'm going to borrow from the hundredths. I'm going to borrow 10 hundredths, or 10 tens, excuse me, and 12 minus 6 is 63. So I'm all set. You can also write this in expanded form, like I did in the previous page. There's one more topic, and it's down here, and it's understanding subtraction when dealing with decimals. So I'm just going to do it here so we have a space to finish on this page. So my numbers were 0.925 minus 0.345. I am lined up on my decimal. I'm beginning on the right, and I say 4 minus 5 I cannot do. Come over, borrow from the 2. That becomes a 1, and I borrow 10 ones. So now I have 14 minus 5, which I can do, and that's 9. Okay, 1 minus 4 I can't do, so I'm going over here to the 10th column. In the 10th, I'm going to make that an 8, and I'm going to make my 1 now an 11. Okay, so 11 minus 4 is going to be 7, and then 8 minus 3 is going to be 5. So be careful how you write these or how you read them, because I think I probably messed up as I was doing that. So this position is the tenths, this is the hundredths, and this is the thousandths with th on the end of each of these. So you're always still borrowing in groups of 10. So the algorithm approach is still the same. So when that completes the notes for Chapter 3. So look through the practice activities, see if there are others that you might want to include in your interactive notebook, and work on the rest of the problem set.